Today's video will be creating a pattern called explosion from Peter Stevens' book Patterns in Nature. So basically, to summarize the concept in his book, he tells that in any given 2D space at least, organic patterns can only take 4 different forms, and they could either mingle with each other and create unique forms like that. So basically, while I was going through Pinterest, I found someone who kind of briefly summarizes these concepts in Rhino 3D, which is a algorithmic generation tool which you use to kind of create 3D models and procedural generation stuff, right, using maths. And it was kind of fascinating to see you could kind of create this in a artificial space. So that's what I was interested in, and so my kind of approach to this was, well, I'm just starting to program, so might as well give it a shot, right? Take up a project and see what happens. I want to make one thing clear before we get into the series. I haven't done all the 4 patterns listed in Joseph Claghorn's post. Part of the reason being, there is really no enough documentation out there on how to achieve that generation using any program, really. I have found someone else using P5JS and I have contacted them to review my code. So enough with that, and let's start with today's video, which is explosion, a type of pattern in nature which can be easily summarized as taking a central point in any given space, or we call the space point cloud, which basically means a given n number of points randomly distributed with uniform distribution in any basically shape, right? So for example, I'm just going to draw one quickly for you guys. This is going to be our point cloud's boundary. It could be really any shape, but for a circle, how we distribute the points differs from how we distribute a point in a square. So I'll get to that later on when we make the point cloud in P5JS. So the circle here is our cloud, and this is going to be our points basically. There is a confusion between a 3D point cloud and a 2D point cloud. So the first time I was searching for a point cloud online, everything I saw was based on 3D scanning and it's 3D point clouds, and it was like I have literally no idea where to search a 2D point cloud, you know. So this concept comes directly from Claghorn's post. I'll link his blog post in the description below so you guys can check him out. So this is our point cloud, and what we want to do here in explosion is that find a central point. It could be any point. For the sake of our video, we're going to take the centermost point. So that means the point closest to the center, which is I'm guessing this one or this one, and we'll connect this point to every other point in the point cloud, something like that. From a central point, it just explodes, right? So where does this come into nature? How can you use this algorithm or whatever to generate stuff? One of the examples in nature of explosion pattern is obviously a dandelion, which is, you can see there's a central point and all the points just explode, creating this organic beauty. So you could arguably use this for also like flowers and stuff like that. Flowers would be a combination of spirals and explosion, I suppose, but yeah, I mean the applications for these algorithms are really just the sky's the limit, really. You could use this in procedural systems, in games, in architecture, you know, pretty much even in robotics, 3D printing. I mean, I think only the sky is the limit. So let's start with defining a couple of variables. So what do we need for a point cloud, right? First thing we have to do is distribute the points in a point cloud so we can connect them in an explosion pattern, right? So let's start with number. I'm gonna give the number as 400, right? So 400 number means we're gonna distribute 400 points within a given area. and also we need a radius. And since we have so one thing to point here, something I found a little bit weird in my experience of creating all these patterns, is that if you want your radius to be 400, you have to halve the value. I don't know why, but that's how it works. Maybe it comes after we translate it, but I'm still not sure. So if you guys figure out why, please let me know in the comments below. So these are global variables. We have a number of points we need to be in the cloud, and a radius, and that radius is going to be the radius of our circle, a point cloud, right? Next thing we want to do is obviously give it a background. We make it black for now, and now we can start running a loop. So we can say for let I equals 0, I less than num I plus plus. So within this loop we're going to define a couple of variables, local variables. So that's going to be, first thing we're going to define is length. So what are we talking about? What is length? Why do we need it for a particular point cloud? And I think length is only required for a circle and not any other shape. I'm not sure, so I'm gonna explain it really quickly. So here's our circle, a rough circle. The question here is going to be, how are you going to define a point in a circle, right? The points have some relationship to the circle, so we're going to define a point. So for example, what is the relationship between the circle and this particular point? Sure, you can get the Cartesian x and y coordinates and be like, distribute these points in -20, -13, etc. But that doesn't seem to quite work, because in a circle we're distributing it in terms of what is called polar coordinates, which means we are using a theta and a length. So what that means is we can define this exact point in terms of what I said earlier, theta and length. So this is going to be, if I have a center of C, so it's going to be a center, I can define this point as the angle. How much angle is it from the center? So if the angle is going to be like this, it can move here. So for example, this angle is going to be 270, for example. And how far away is it from the center? So if our radius is 4, we can simply give this as 1.3. So we can define a point inside a circle as a polar coordinate, which means we need an angle and a radii or a length, right? So that's what we need a length for. So to define a length, we need a square root. I'm gonna tell you why later on, but for now we're not gonna use a square root. We'll simply give random and 0 radius. So which means we're gonna take a random point between 0 and the radius. Since we're giving the radius, the points can also be on the circle, so that's one thing to keep in mind. If you want to be purely inside the circle, you can just put -1 radius or any number you want that can be inside the circle. So next we have defined, obviously we need theta, and theta is going to be basically random and 2 pi. 2 pi means the whole circle, so we can just say random 2 pi. Okay, so now since we are working with a Cartesian plane right here, or I think any programming language, basically we need to convert this into a Cartesian coordinate. So what we're going to do is we're going to define x chord as length into cos theta, and we're going to do the same here, and we're going to change the sign, cos to sine. Alright, so now we have the points ready, we have the coordinates ready, so it's going to run 400 times and we're going to get 400 unique point, right? So for example, we can quickly visualize it by circle x chord okay, so now we play it. Now immediately you can see one problem, and that is the circle itself is close to the 0 0 of our canvas. So we can simply avoid this by translating the values. We can say translate width by 2, height by 2. Height by 2, width by 2 basically means the center of a given canvas. Our point cloud is ready, but we do have a slight problem, and I'm going to visualize the point cloud for you guys right now. So here's a point cloud as we mentioned earlier, but you can see the points are distributed unevenly through the circle. The density of points in the center is very high compared to those in the outer parts, outer regions. So that means as the circumference gets higher, the density is remaining the same. That means like for the smallest circumference, the density is equal to 4. So when it comes a little bit higher, if the circumference is 1, the density is 4. So when the circumference becomes 8, the density is still 4. So as you can see, the points will be distributed farther away as the circumference get higher and higher, right? So an easy way to fix this is obviously, as I mentioned earlier, simply using the square root will solve this problem. So I'm going to take the square root of the length, and now okay, so guys, the reason this is not working is we have to multiply the square root by the radius itself. So now it's going to work. Yep, it's working. So I'm going to give the random function here. Okay, so now we have the point cloud in a uniformly distributed density. That's what I like to call it, or maybe it's the real term. I do not know. What it means is that it doesn't matter what circumference you're on, the probability density is always going to be the same. The next step to create the explosion pattern is to find the centermost point in the given point cloud. So this sounds as easy for you and me because I can look at the picture and I can find, okay, closest to the center is going to be this guy, right? Or even if I had a reference, it's going to be way more easier. I can just take this circle and give him a white color. I can say 5. So now we have the center defined for us, and we can say, okay, so which is the closest to the center? I don't know, this circle seems closest to the center, and we can take the x and y coordinates of this point, and using that point we can connect to the rest of the points in the point cloud. So for this reason I'm going to reduce the number by 100 10 times. So now it's going to be 40, so you can see what's going on very better, more clearly, right? So we're gonna keep the center and the white circle here because it's going to help you better understand what we're gonna do. So the first thing we want to do is take all the points and push it into an array. right, of x and y coordinates. We can do that by simply defining again a global variable, because you could use this in a different function to kind of clean up your code, but for today's video I'm not going to do that. I'm just going to keep everything inside the function to make things easier for actual beginners, you know. So let's define two arrays. We're gonna define xr and yr, and we're gonna define them one array, two arrays. So we have two arrays, xr and yr, global. So which means I can literally just go here and say xr dot push x core, and I can do the same for the y coordinate, I mean the y array. By the way, if I'm stuttering a little bit and kind of pausing here and there, it means I haven't scripted for this video. I'm just making the video on the go. I really wanted to share this with you guys, so I'm gonna go through again what's going on really quick in case you have kind of confused yourself with. So we're running a for loop and it's going to be less than the number. So the given number is 940. So since we're starting with 0, it's going to be 40, right? So I++, which means you guys know the for loop thingy. So we are defining a length each time the for loops starts at the beginning. So each time the for loop is called on, the length is redefined. Okay, so the length is not going to be the same as before. Each time there's a new length, and the length is the square root of random, which means 0 to the radius amount, right? Random, radius into radius. We're multiplying the radius because we want a uniform distribution within the point cloud, and theta is going to be random 2 pi, which means 6 point something, which means the whole entire circle angle, right? So again, we are saying x coordinate is going to be the length into cos theta, y coordinate is going to be length into sine theta, and we are pushing those two coordinates into the x array and y array we have defined right now. So if I go to console log, if I put x array, we're going to have 40 different x values. So yeah, so the next thing is obviously finding the closest guy to the center, which fortunately we have the center. We know the center because we translated it to be 0 0. So we have to find the closest point to x and y. So how are we going to do this? I have tried a couple of methods and painfully none of them have worked. To actually get the closest point is obviously in terms of distance. Again, we're going to use a distance function, which is already described in mathematics for us, and I think you guys have learned it in your high school or middle school, I think. So distance function basically means we have a set of points in the circle, and we're gonna take the center as our x1 and y1, and we're gonna scan the radius. Okay, so we're gonna go till here, this point, and we're gonna take this point's x and y value, and the function goes like this: d equals the square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is going to give us a distance between the points we have inputted. So our center point is always going to be the same for each iteration, and the other points are going to be the points within the array we are giving the iteration of, right? You understand? So I'm gonna type it on so you guys know what's going on. So within this array, what we're going to do is define the distance function, or you can define the distance function outside, which I'm going to do. so we can call it anytime we want, right? Function distance. What are we taking? So we're taking x1, y1, x2 and y2. We're gonna return math dot, you can also take the absolute value, but nobody really cares, so I'm gonna go straight to square root of an other bracket. We're gonna say math dot power x2 minus x1. So basically power means square, so 2 times means we're just squaring it, and 3 times maybe like x raised to 3. So this is going to be our function that I described earlier. Distance is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Right, so this is going to be a distance function, and we're going to say let x2 equals x array I, let y2 equals y array I. So since we have already defined the center, we already know the center, we really don't need to worry about giving a variable to hold the center. We can just put 0, we can just pass 0 into the distance function. So we can say let d equals distance 0 0 and x2 y2. So we have the distance completed. So now we're gonna define a variable. We need an array to hold the variables, right? Hold the distance. So we're gonna say let dist array equals to an array. So I'm gonna say dist array dot push d. So now if we quickly console log this one, by the way, the reason I'm making too many typos is because I have the mic straight in front of my face, in front of my hand, so I cannot see what's going on down with the keyboard. Dist array. So if we console log this, we're gonna get the distances of, like you can see, literally 120, all the distances. So out of this distance array, we are basically going to take the lowest distance. So which basically means, a simple way to do it is distance array, or we're gonna make another copy of the distance array. So we're gonna distance array sort equals distance array dot sort take AB and return A minus B. So what this basically is going to do is it's going to sort the array from ascending to descending order. I mean ascending order from smallest to biggest. So now if we take a look at dist array sort, oh, I'm sorry, I forgot to make a copy, so that's important. Now we have the original array on the top, so this is 70, 80, whatever, and we have a copied array which is sorted as well. So we can see 90, 37, it's going in ascending order. So now we simply have to get an index. Let index equals dist array. We're going to get the index of the first value. So we're gonna get this index value, I mean index of this value 29 within the original array. So it's going to be here, right? And the reason why we're doing this is because we are pushing the values inside the distance function in order that is equal to the order of this array. So the first distance function x and y coordinate is going to be 0, second like it's going to be 1, 2, 3, etc. So if we get the index of the smallest value of the sorted array and we get the index of that value within the unsorted array, that index is going to be equal to the x and y coordinates within our x and y arrays. So we can take that coordinates and we can just paint a picture. So that is going to be our closest value to the center. Hopefully I'm making sense, but I think you guys can ask me any questions in the comments below. I will try to answer to them to the best of my abilities. So as I said, index is equal to distance array dot index of distance array sorted 0, because this is our first value, and first value, since it's sorted, it's always going to be the smallest value. You can also use a closest function, like get the closest value to a defined input, but I think this is a much easier way to do it. So since we have the index, I can simply say circ fill, and I'm going to make this green. So now we can see we have the closest point to the center as green. It's always closest to the center. So that's one step out of the way. So the next thing is pretty simple. Since we have the closest point to the center, we simply need to draw a line from the centermost point to all the points in the point cloud. So as you might have guessed, the easiest way to do that is iterate through all the points in the x and y array and always keep the x1 as the centermost point we have defined. And what I mean by x1 and x2 is that line function is going to ask x1 and x2 to draw the line. So I think it's a pretty good option to just define these two variables. From now on it's going to be pretty simple, so we're going to run through the loop for let I equals 0, I less than x array dot length. We can also do the x array dot length, we can replace that with number because we have defined a number variable, and the num variable and the length of the next array is always going to be equal. So as I mentioned earlier, we can define the let x2, and the reason we already have an x2 and y2, but I think it's simple to differentiate, but it's a good practice that you don't have multiple same variable names even though they are local, right? So if you have like billion for loops, and if you want to go through each one, you might get confused on which for loop is which. But for the sake of this tutorial, we just have two loops to go through, right? It's such a simple pattern process. So we can say x array. So we're going to draw a line from x1 line, y1 line, x2, y2. The stroke is going to be, okay, we're going to keep the stroke as yellow for some differentiation, and we're going to keep the stroke weight as 2. Okay, so now hopefully it works. So now voila, we have the explosion pattern. I'm just going to increase the fill of this one by 6 so you guys can see where the points are at. So here we have the points, and the explosion is connecting from the centermost point to all the points in the point cloud. Even if they increase the number, it's going to work so beautifully. Let's put 600. Obviously it's going to get complicated, it's difficult to see, but it is working definitely. So that's it guys for today's video of part 1. Hopefully there are more parts to this video series of patterns in nature, but quick note, I haven't completed all 4 of them. There is 2 still remaining, and meander, I was talking earlier in the video introduction, isn't quite complete. It is complete, but it's not quite there yet, and I'll probably talk about it in the next few videos about what difficulty I'm facing creating a meander pattern, and hopefully someone watching could help me out. And yeah, I mean, branching is already done, it's working perfectly, so the next video is probably going to be branching, which is a little bit of a step up from explosion because it involves several different functions and several different arrays, so it could get kind of confusing of which array we are using and which array we are removing the values from. But hopefully the next tutorial can be a little bit scripted. I'll try to script it a little bit so you guys don't have to sit through and listen to me babbling or stuttering here and there and making mistakes down the road. Yeah, hopefully you guys enjoy the video. This is Explosion, and I'll see you guys in the next video. Bye bye.